it's a lovely weekend. I've had a good day, and I know you've also had one. This is Facts of Health. You are welcome to the show. This is where you get to know all you need to know about your health. After a stressful week, you need to start another with good health and knowledge on that. For tonight, I have two guests here who would help us for our topic, which is sickle cell disorder. And there are two beautiful ladies in the presence of Dr. Grace Amu from the Ghana Institute of Clinical Genetics. She's a medical officer. And Mrs. Esther Tobo, a nurse tutor from the Public Nurse Training School, Kolebu. We are streaming live on Facebook. You can search GNTV Ghana Network and you can follow us. You can also follow us on all our social media pages. Facebook, Facts of Health. Instagram, facts.of.health. Twitter, @factsofhealth1. Twitter with the spelling Facts, capital F, capital O, and capital H. You can also subscribe to our YouTube channel and you can follow us there, Facts of Health. My dress is beautifully done by BMS Clothing. You can call it on 020-8499-671. You can locate her at Mamprobi Kamara. My hair and makeup is beautifully done by Penis Experience. You can call on 054-18-32737. I am Na Edu, your host for this show, and this is Facts of Health. Stay tuned. If you just tuned in, this is Facts of Health. I am your host, Na Edu. You can be part of the show by sending your messages through 050-1432-820. I'm here with two beautiful ladies, as mentioned earlier, Dr. Grace Amu and Mrs. Esther Tobo, and we are discussing sickle cell disorder. Ladies, you are welcome.
Thank you.
How's the weekend going?
Cool.
Fine, cool. You went out. You went out today.
Not bad.
Not bad. So you didn't go out.
No.
No, doctors. Yeah, my life, no, and rakaka. Mrs. Tobo,
Yes, dear.
how are you?
Good by grace.
The whole weekend,
Very good.
and the week was
Good.
good. All right. So we'll jump straight to our topic. Dr. Amu, we are discussing sickle cell disorder. Our first question would usually be, what is sickle cell disorder?
Yeah, no, thank you. So, it's a good topic we are discussing because it's a topic that everybody needs to know. So, sickle cell disorder refers to a group of conditions that affects the red blood cell. And going back to the basis, the red blood cell, so everybody has blood.
Yeah.
And the blood has different components. One of the key components of the blood is what we call the red blood cell. And the red blood cell the blood is red because of of a protein which is called hemoglobin.
Okay.
Now, sickle cell disorder arises from variations that occurs in the hemoglobin. The normal hemoglobin is called hemoglobin A.
Okay.
And virtually it's a protein. Virtually every structure in the body every trait in the body is made up of proteins. So that the proteins are produced by the DNA, which is the genetic material of the body. Now, for every individual, the sickle cell, the hemoglobin you're expected to have is hemoglobin A.
Okay.
And
That is a general one that you need to
Yes,
have.
so that if somebody instead of the normal hemoglobin A has a variation,
Okay.
which is either hemoglobin S or C, then the person is said to have sickle cell disease. So
Okay.
a person is supposed to have hemoglobin. You get one trait from your father and one trait from your mother.
Okay.
So that if you have AA, that would give the normal hemoglobin.
All right.
But then if you have one A and then you have an S, then you are said to have a trait.
Okay.
And if you have SS, then you are said to have sickle cell disease
Okay.
or sickle cell anemia.
All right. Mrs. Tobo, I heard her mentioning some variants from her definition.
Yes.
I wanted to know the variants, what really they are.
Before I go to them,
Okay.
I want to use this opportunity to say good evening to all those looking
Yeah,
and listening to us
various.
this evening. We love you all. In fact, from what Dr. Amos just said, there are different types. Like how she said, if the father is AS, the mother is AC. If their AA meets, it's normal. But if they are AS and then, or if they are S and then the C meets, then you have the sickle cell disease,
Okay.
right? So there are other types that we have. We have the SC. One can have SC, that is from AS and AC.
Okay.
Or you have SS. That is if, let's say, the daddy is AS, the mom is AS, and then the S and S meets, right? And then also you can have the beta-thalassemia, right? And then some people even ask that I'm AS, but they said I'm sickle cell. Is it true? They call and then ask all those questions. But the main thing that we are so worried about is our patients who always come with who have the AS, who have the SS and then the SC.
Okay.
Yes.
Okay.
That's the main one.
That is the. I heard you mention AC. From that brings me to last week's episode. We mentioned AC as testing negative. So if I'm AC and I've tested negative, why would I go further to find out who I really am?
If you are AC,
yes,
and it is negative,
I've tested sickly negative.
Yes.
I don't know that I'm AC.
Yes,
but I've tested negative.
I think I can.
Okay.
Okay. So the whole issue with sickle cell disease is the complications, because what we know is that sickle cell SS is about the most severest form of sickle cell disease.
Okay.
Yes.
However, sickle cell SC is of huge public health importance. Why? Because back to what you said, it's important that everybody knows their sickle cell status.
That's the
and
genotype.
Especially because of the chances of transferring it to your child.
Right.
So that what happens here is you would have somebody who is normal, has no problem, has no complication.
Okay.
But then the person could be a carrier, in which case we are talking about AS or AC. Now for the person that is AS, with the usual investigation that we have known, which had been the Sickling test, it would easily be picked up as Sickling positive. And so you would know, because of this, you would know that you have to go further to know your genotype.
Okay. Right.
But then for the person that is AC, the person a Sickling test would have shown that the person is Sickling negative. And so the person might not see the essence of going for the further investigation, and is just comfortable and might assume that I am AA. And then this is where the issue we are talking about comes in, because then you may marry somebody who is AC
or AC.
AS, and because you are assuming you are fine, you are assuming you are AA, you end up with a child who has SC or any of the sickling conditions we are talking about, and then you don't understand because you had begun by assuming that you were AA. So yes.
So you're advising we have to go further.
Yes.
From sickling test.
Yes.
So whether you are positive or negative, you still have to go further.
Yes.
Okay. All right. So that brings me to the question: the differences between the sickle cell disease, the traits, and then the anemia. If you can help us with that, Mrs. Double.
The sickle cell disease,
Yeah.
and then the anemia. Those who have the SC and then SS, right? The anemia are those who normally have the
SS.
the SS,
Yeah.
those with the double S.
So
Right.
that's full.
That's the full. They always exhibit the signs of the anemia more than those who have the SC. But
Yeah.
Okay. So
I don't know whether probably
The-
going into a little deeper science would help.
yeah.
Okay, so what we are saying is that we began by trying to explain what happens in the hemoglobin.
Okay.
So we began by saying that there's a DNA which gives the coding for the protein. Now, when you break proteins down, you get what we call amino acids. So that it is the different proteins in our body is determined by the sequence of the amino acid.
Okay.
Now, what happens is in formation of the normal hemoglobin, there's a particular sequence, and in position 6, on position 6, you are supposed to have glutamic acid. Now, in place of the glutamic acid, in sickle cell S disease or hemoglobin S disease, then what happened is that there's a single change. We mentioned that it's a genetic condition.
Yeah.
So within the gene, there's a single change of the amino acid. So that instead of having glutamic acid, we have valine. Now, this doesn't affect the length of the hemoglobin, that it affects the nature
Okay.
of the hemoglobin.
Okay.
So this person then has hemoglobin S. We also mentioned C.
Yeah.
Now what happens in C is that it's similar to the S.
To the S.
But in this case, in place of the glutamic acid, you have leucine. So the amino acid leucine. Then that results in an S. In thalassemia, what happened is that this is not a change. It's the hemoglobin is made up of like about 4 protein chains.
Okay.
Then it has an ion,
In there.
and then that is what helps it to transport oxygen throughout the body. So what happened in the thalassemias is that instead of the normal length, it is cut short. So there's a variation in the length. This could happen on. Okay, so there are 4. Maybe we don't need to go much into that. but
No, you will need to go much because
Okay, so
for the sake of my viewers, because we have a lot of misconceptions out there. So
okay.
if we are going deeper, I think that is the main purpose of the program. It's for us to go deeper, not shallow.
Okay. All right. So we are describing the hemoglobin protein.
Yeah.
We are saying that the hemoglobin protein is made up of 4 protein chains or globin chains and then an ion.
Okay.
So 2 of the chains are called alpha chains and the other 2 are called beta chains. So that when it comes in naming the types of in sickle cell disease, the problem is on one of the beta chains. It's on the
Okay.
beta chain. And we are saying there's no variation in the length.
Wait, explain that beta change.
Oh, that is just how they are called.
Okay.
It's just how they are called. So they are called alpha chain and beta chain.
Okay, so they are just names
Like the
that are
Greek
given.
form A and V. So
All right.
alpha chain and beta. So that's just what they are called. Yeah, so it occurs on the chain which is called beta chain
Okay.
on the position 6.
All right.
Okay. So in this one, there's no problem in the length. It's only the response and the character. And the response, and then, and it is the way it responds to oxygen. In the absence of oxygen,
Go further.
in the absence of oxygen, so what we say is that whenever the cell undergoes oxidative stress, so anything that it takes out more energy, more oxygen from the cell, it responds differently.
Okay.
So that when you look at the normal red blood cell, we can picture it like a ring donut.
Last our previous episode, I think Mr. Mensah mentioned donuts, and then the way he was giving the choppings and all that. So he was trying to tell us the differences because of the different choppings and then the groupings. Because I know a lot of people confuse the sickling with blood groups.
Yeah. And that is why I really like the ring donut.
The donut.
The second ones to
Yes.
look like banana.
Okay. The second one looks like banana.
So like when you pick the ring donut bit of it, then what happens is like the picture is that the hemoglobin is like the white or the yellowish bit,
All right.
and then the brown coating is like
Oh,
the
that sounds
like the membrane.
It feels good too.
And then you see some people go further to add some sugar.
Yeah.
So if somebody wants to understand what the blood groups are, yeah, the sugar is the tax.
Yeah.
So at least that gives a better illustration. So
Okay.
the white hemoglobin is what we are talking about, and then we are saying that this is when the body undergoes oxidative stress or anything that stresses the body so much or removes oxygen from it. Then they assume a different shape. So normally the red blood cell is very flexible, can really move through the cell freely. But then because of the difference in the hemoglobin, the changes we are talking about here, it's not able to undergo that flexible. It's
Okay.
no longer that flexible. So once the hemoglobin changes, it changes the entire cells, and then it becomes like the banana shape
Banana
or
shape,
the
the second
langa
less.
langa.
So, Mrs. Stubble, with the ACs, you were saying that you will inherit it if you are a child. So, AC can get married, Abby? Mrs. Stubble.
AC and AC.
Yes. Yes. We are not sickle cell. It's CC.
Well, they do have their own issues.
Yes.
I mean,
There
they do
are rare
have
type
their
of
own.
sickle cell, doctor.
I mean, the question is, why are we talking about this problem in the first place? Because, people have been marrying, not
Yeah.
considering genotypes and all that. So how come all of a sudden we are interested in, because in 1990, the World Health Organization recognized that sickle cell anemia was actually a real public health issue.
Yeah.
Because what happens is that they tend to have a lot of complications, especially when they are not diagnosed early and managed properly. And then for every medical or surgical condition you think about, they can have the severest form of it, and that is why it's become of concern to everyone.
So it's not
Okay,
just
so and that is why now we understand that the best way we can prevent it or prevent the burden sickle cell has on society is by prevention. And then how do we prevent it? And that is where talking about the marriage comes in.
Mrs. Stubble, you're a counselor. Wait. Because I know you're a counselor, apart from being a nurse. You are trying to stop someone from marrying you.
From my point of view.
Yes, from a counselor's point of
Okay,
view, not from a nurse's point of
From a
view.
counselor's point of view, I want to recommend AC to marry AC.
Okay.
Because as a nurse, our nurse patients who also have CC, even though it's a rare type, they you can count the number of patients who come to the clinic with CC. So if you are AC, your partner too is AC, and the child is CC, the child has his own crisis that he or she goes through. So why do I have to burden the new child who is coming to this world to enjoy life to have crisis when we can prevent it? So I can advise you that it is love. But it is love. Yes, you are in love, so you can just let us go and get somebody who is AA.
Let the love go.
Yes.
Oh.
So that I get somebody who is AA. I
Mrs.
think it
Stubble.
will help the next generation who will be coming. I don't want to nurse children who are SS and AC, CC.
Percentages. Okay, so we have something on our screen, which we are